This presentation regards some methods about fraud detections through statistics and machine learning, but in particular is focused on an overview of supervised and unsupervised algorithms, which are currently developed in recent years in literature. So frauds can be cast as deviation from the normal transaction data and can be addressed using anomaly detection procedures. Anomaly detection is a broad field that addresses the problem of identify instances of data or events that do not conform to expected behavior. In this perspective, we can use the definition by Hawkins about the outlier or anomaly, which are two terms used interchangeably, where an anomaly is an observation which deviates so much from the other observation as to arouse suspicion that it was generated by a different data process, a different mechanism. So the problem is to identify the data generator process and then to isolate and then to detect anomalies. Anomalies can be classified into three more general different categories according to Chandol et al. Definition. So to simplify, we can have in a data set some anomalies referring to a single point, to a single individual, to a single record, a single instance, which is anomalous with respect to the data distribution. Or we can have also anomalies which are a collection of instances, which is considered anomalous. Here in this slide, you can see, for example, an anomaly related to the electrocardiogram, for example. So in this case, the anomalies is not a strange deviation, a large deviation from observed data, but simply is constant. And this constant, this straight line, is anomalous with respect to the collection of the data. Another type of anomalies is contextual. For example, in time series analysis, in time series or in space data, anomaly can occur because they deviate from what is the expected behavior of the time series, as in the example shown in this slide. Of course, there are several ways where anomalies represent the data, and are not always simple to identify, simple to define. In particular, in fraud detection. So, in fraud detection, it's difficult to define a normal region to encompass all possibility of normal behavior, because more often the multivariate data is composed by variables which are related by complex relationship. Also, anomalies may arise due to malicious activity or which are often changing and adapting during time. This is the so-called consent drift, which can limit the application of standard anomaly detection procedure. Also, anomaly can vary from different domains and applications. So it is not possible to define, to build a anomaly detection procedure valid for all the domains and applications. Another challenge in fraud detection is represented by the lack of labeled data, which are useful for training and validation of models, but for several reasons. For example, because the presence of sensitivity data, or because of costs related to survey, for example, not always is possible to have labeled data, so to have information about fraud or the presence of the absence of frauds, for example. Another challenge, which is more important, is related to the occurrence of event. In particular, anomalies are often rare in occurrence. So their identification risk to be more complicated because the number of anomalies respect to the normal data is much more limited and so difficult to identify. Another problem, last but not least, is related to the course of the dimensionality. So when we have dataset, large dataset with a lot of variables, identify anomalies becomes more difficult because of the high dimensional spaces of the dataset. So when related to the fact that we have no labeled data, so we don't know which are the records related to presence or absence of fraud, etc., it becomes difficult also to evaluate the performance of any of any outlier detection method, anomaly detection methods. The performance evaluation, in fact, the standard metrics related to performance evaluation, for example, the precision, the recall, the phone score, l'area, ROC, are related to the presence, required presence of labeled data. But without labeled data, such a measure suffer and are not always representative of the performance of an outlier detection procedure. So the question is, which is the best performing anomaly detection algorithm for fraud detection for this specific case of analysis? So, of course, statistical-based procedure, standard statistical-based procedure, for example, those based on theta score, t-score, box plot, or are not useful for this kind of data. Also, model-based approach are limited because model need to be specified correctly with respect to data, which, as I said before, not always the relationship between variables are not always linear, are not always simple to model. So, in the following, we report the main results highlighted in a recent paper by Hilal, published in 2022 in Expert System with Applications. Such a paper is entitled "A Review of Financial Fraud, a Review of Anomaly Detection Techniques and Recent Advances," where the author expose all a comprehensive review of machine learning approach, essentially, developed for fraud detection. So before illustrating the approaches indicated, described in the paper, it's important to distinguish between several approaches for anomaly detection: supervised, semi-unsupervised, and unsupervised. Supervised anomaly detection are the more obvious approaches. So models are designed to detect anomalies in dataset where we have availability of labeled example. So we can train data, test data, having availability of both normal data and anomalous data. Semi-supervised anomaly detection models instead assume that the only instances in the datasets that are labeled are the ones belonging to the normal class. So it is a little bit restrictive with respect to the supervised approach. A model is then constructed only for the normal class and not for the anomalous one. Then the test set of the data is then compared against the model to identify anomalous instances. Finally, unsupervised anomaly detection are models do not require any labels in the data. So an implicit assumption is made by unsupervised methods that anomalous events are far less frequent than normal events in the test set of data. And given this definition, this description, the latter, the unsupervised anomaly detection, seems to be the more favorable to deal with fraud detection, where not always we have labeled data. So the authors in the paper before that I have mentioned before report a number of methods that have been applied to fraud detection. In particular, several supervised anomaly detection algorithms have been applied, mainly based on vector machine, neural networks, convolutional neural networks, and long short-term memory networks, the latter more suited for time series. So here I report the tables of the paper where there is a list of paper published in the last year where supervised machine, neural network, or convolutional neural network methods have been applied to fraud detection. So as you can see from these tables, you can see that every method, every paper do not perform the standard method, so the standard supervised machine or the standard multi-layer perception. So each method is calibrated to the data, is calibrated to the type of fraud. So we have for each paper a new method that has been applied to solve to perform fraud detection. So this is just to answer the question I have put before. So which is the best method for fraud detection? There is not a unique solution, as you can see. In addition, here we are we are the list of supervised methods which require labeled datasets. So each of these papers are an implementation of particular supervised outlier anomaly detection method, and the performance of such a method has been tested on dataset, on labeled dataset, which are not always the case for fraud detection. So in the same paper, Ilal described two methods that are referred that rely to unsupervised and semi-supervised anomaly detection procedure. Such methods are the autoencoders and the generative adversarial networks, which so such two methods are recently developed for fraud, so are developed for order coin in general for order context, but are recently applied for the purpose of fraud detection. In particular, autoencoders is an unsupervised anomaly detection, unsupervised machine learning, which can be used for anomaly detection. How works an autoencoder? An autoencoder has a structure similar to a neural network, a multi-layer perception, but the primary difference with respect to a multi-layer perception is that the number of neurons in the output layer are equal to the number of input, so the data. In particular, the autoencoder-based algorithm consists in two parts. The first part is an encoder function, which starts from the input data and convert the input data in a zeta codings, and a second part where a decoder function x prime produce a reconstruction of the a decoder function gdz that produce a reconstruction of the input x prime. So how to learn the neuron weights and thus to produce the zeta codings, the autoencoder first seeks to minimize some loss function, such as the mean square error, that penalize the distance between the output x prime and the input x, the data input x. Since this last function measures the reconstruction error, so we can extract this information to identify those observations that have large error rates. And then using these large error rates, we can identify anomalies or outliers and from original data. Note that autoencoders are unsupervised based learning, so we have not labeled data in the data input X. So the process produces zeta codings. From zeta codings, we have the output. So we have a new a reconstruction of the input data, then a comparison of the input data with the data reconstructed from the zeta codings, and then from this comparison, which of course require iteration, from this comparison, after a number of iterations, we can isolate those data that do not conform, that are dissimilar between each other. And this difference, so instances that have large difference between X input data and X prime output data can be identified and flagged as anomalies, as anomalous. Another algorithm which has emerged useful for fraud detection, or better, useful for anomaly detection and also for fraud detection, is the generative adversarial networks, GAN. A GAN is a semi-supervised learning when used for outlier for anomaly detection, but of course have some advantages with respect to the supervised learning, which require labeled data as input. So a GAN involves two deep neural networks, a generator network and a discriminator network. The generator's role is related to produce synthetic data, for example, by adding random noise, and aim to convince the discriminator, so the other network, so to convince the discriminator that cannot differentiate between real and generated data. At the same time, the discriminator is trained to become more adept at distinguishing between real and generated data. So the two networks work in adversarial way. So the objective is for the generator to create data that is increasingly realistic, while the discriminator becomes more skilled at telling the difference between real and synthetic data. Such a process continues until the generator produces data that is essentially indistinguishable from real data. And when such a condition is reached, we have an equilibrium point, so the algorithm stopped, and we finish to train again. How to detect anomaly with GAN? So there are several ways to detect anomaly. One way is to select instances after the training stage, select the instances that are dissimilar to both the real and synthetic data. Or another way is to select instances that discriminator classify more likely to be synthetic, so to be fake. So these two approach, GAN and autoencoder, have been proven to be superior in creating more realistic samples with respect to neural network, for example, or other machine learning approach. And have also proven to be preferable with data set characterized by a low rate of occurrence, so where it is necessary, for example, to undersampling the majority class instead of oversampling the minority class. The limitation of both approach are related to some tuning, some additional tuning compared to machine learning like supervised machine or random forest, which are ready to use. But of course, such a limitation could be compensated by the performance in anomaly detection. So I have finished.
5 minutes.
Okay, so it's just one slide, I think. So the literature review show that there is no a single universally applicable anomaly detection technique for all different type of financial frauds. From the survey literature, there is, however, a clear shift in trend, a clear tendency towards adopting unsupervised and semi-supervised methods as opposed to supervised model which require labeled data. There is an evident lack of publicly available datasets, which are essential for testing, for calibrating model. So this is a point which need to be highlighted. And more important, the imbalanced nature of dataset due to rare occurrence of fraudulent cases was emphasized as one of, if not the most important critical point during the design stage of any fraud detection system of model. In addition, even when datasets are labeled, it is often the case that not all instances of fraud have been detected. So the problem of having a labeled or unlabeled dataset is irrelevant if we consider that the labeled data could be misclassified. So this is just a presentation of the literature result, and we think that to implement some of these algorithms are already available in our software, in our packages. So the computational efforts are not so higher. Are not so high to be do not constitute a limitation. So the next step is to apply such a procedure, such procedures such as autoencoder and generative adversarial network to real-world data, to data from survey, for example, or of undeclared work, which have been already used in other work, and see what are the performance of such a model for future application.